It's 9:11 p.m. It's Joel Walsman, CEO and Master Electrician of Jefferson Electric. Zachy, the lead man, and Andy, the smarty pants, get all the credit. But today, we're going to show you part 2 of how to do this and that rooftop solar, Tesla gateway, span panel, start to finish, 9 guys, 16 hours. Let's go.
So where we are now, we've passed inspection, hooray. We have all of our supply and our loads into our gateway, Tesla gateway. We have yet to run our feeds down for our power walls. This is where the power wall is going to go. We're going to have 2 in a stack kit, so one in front of the other. We've got our inverter up, totally wired, ready to go. They're almost done on the roof. Panels are getting close. We have our span panel installed, and the main feeds are on and landed. And all we have yet to do is lace everything in, get our grounds and neutrals in. This is a second means of disconnect, or third, so we cannot bond our grounds and neutrals together. So we're going to have those separate through this system. But we're getting close. We're making progress on the job.
All right, so this process is just the painful, really painstaking is better. Lacing into the panel. I'm doing grounds first, then I'll do neutrals, then I'll terminate all the hots. As I'm terminating the hots, I need to make sure when I'm cutting and stripping the wire, I preserve the labels so I've got total clarity on what that is, because having to jump in the house and trace things out is extremely time consuming, of course. I want to give you a couple updates here on span and Tesla Powerwall. First, the Powerwall. This is the Tesla Powerwall 2. It is an AC coupled battery. That means that literally the bottom portion of this Powerwall from here down is lithium batteries. From here up, there's a radiator to cool the process. There's an inverter. So power is going to come off the roof and get turned by this SolarEdge inverter. BTW, SolarEdge is like 50% of the US residential market share, and that's because they're so dang good. Israeli-based company, extremely innovative. Love to see what else they're going to have coming out. So solar panels produce DC energy. Comes into the inverter. Where is it coming into the inverter? Right here. This is our DC in, and we've got 2 strings. You can see the red and the white-red, black, white-black. Then we've got a spare string that we ran to have for future. So it comes in as DC, comes out as AC. From there it jumps and lands on the 2-pole 40 amp breaker here. We fished that through the wall for a good clean finish. 2-pole 30s for the power walls. We used a Powerwall stack kit, as Andy described. That is a kit, comes for about $150 from Tesla. It's got some finishing on the side. It's got this nipple, and it's got a guide to show us exactly where to drill that hole through the face. You can stack power walls up to 3 deep, but only if they're on the floor. Wall mounting power walls is accepted if the wall has sufficient strength, like a standard 2x4 stud wall does. However, you can't stack them on the wall, only on the floor. Obviously, 275 pounds a pop, that's self-evident. This is the Tesla Gateway 2. This is beauty. When you see this cover go on, it's going to have the same clean finish that this does. It used to just be like a gray, generic-looking metal cabinet with the Gateway 1, but they really upgraded with a beautiful white glass front and the Tesla logo, so I'm proud of them for that. Span, like Tesla. Now, Tesla will definitely void your warranty if you aren't installed by a Tesla-certified installer. Span, I believe, does the same thing, and that makes total sense because you've got atypical, start to finish, atypical installation here. So you've got standard breakers. Span accepts any standard 1-inch breaker like this, residential plug-in, except GE. And so these are all new breakers for the installation. You've got cooling fans at the bottom, neutral bars on the side, grounds on the right, neutrals on the left. You've got main lug guards, which I love, standard square D home line main breakers. So the hubs on top, the main breakers, which I think you can use any standard, 100, 125, 150, 175, and 200. So that's really versatile. They've also got feed-through lugs at the bottom, which I love. That's a must in every panel, in my opinion, but it's not a reality in every panel. So you can feed through full 200 amps from the span. Now, if you do that, span is only monitoring these circuits. These are the only microchip connected circuits. And so if you feed whatever the sub panel is, it's not going to have the span circuit level intelligence. That's strictly just a set of feed-through lugs for a sub. This is an outdoor rated panel, and that means you can install span on the outside of the home. We're going to be putting in trim kit because we've got drywall, and that's why we've left this drywall up here, is because we want that trim kit to go on nice and clean, and the drywaller not to have to try to slip that in and finish it after the fact. So that's a good clean finish for the interior. Span also needs communication, just like the Tesla gateway. Again, the gateway is the brains of the operation for the Powerwall system. We're going to have full monitoring and intelligence on all three platforms. SolarEdge is going to give us module level data, insights, and reporting. Module level. That means every solar panel is going to be individually reporting to the customer, to SolarEdge, and to our office so that we can see in real time if there's a failure fault of any kind. Not just with the array as a whole, but it will flash us a red X on the monitoring platform under our customer's name to draw our attention. Now we've got about 500 sites, but it will prioritize sites with outages. So that's good. SolarEdge, free app, free lifetime monitoring. Tesla Gateway 2, also free app, lifetime monitoring. This is neat in that we've got some CTs, which are not landed yet. CTs are current transformers. It's not plugged in. But the CTs will monitor, here's the other end, will be installed and will literally just be little current clamps, little black donuts around the conductors so that in the Tesla app, you can see how much energy in real time is being produced from the grid, from solar, from battery, what the battery level is, and the span then, the free lifetime monitoring, again, the span app will provide circuit level data and intelligence. Check out this little clip right here if you're interested in more on span. We've done numerous span installs and it's a tremendous value add. Let me give you the quick value matrix here. Powerwalls installed are like almost 20 grand a pop. So it's a real investment. If you integrate span into that equation, the intelligence monitoring and control that you have with the span panel, it's so robust and it's automated. So if you're sleeping in the dead of night and the power goes out, span automatically takes control and it follows your predetermined course of action during an outage. That, in this case, this is what span does. Without span, you'd need 3 Powerwalls, possibly 4, to do the same kind of thing as you would with a span panel. So span installed is anywhere from 7 to 12 grand, depending on your situation, but it's going to save you that extra Powerwall or two. So it's just absolute beauty and efficiency. I'm a pretty big fan. It's going to be neat to see what they do long term because there are a lot of integrations coming down the road. I've got more for you, but you got to stick around for that. Back to work.
I expect to meet a substantial portion of the energy needs. Obviously, by installing 2 Powerwalls, I should be able to transfer energy from the daytime to night. But the biggest issue is going to be moving between seasons. Since we don't have net metering, obviously I can't sell it to the utility company at anything close to my the price I had to pay. I think my marginal electric rate is about 11 cents a kilowatt hour to buy and about a little over 3.5 cents to buy. So I'm going to lose out on that deal. So I don't know quite how to do it, but we'll see it in the future.
Camden, what are you doing down there?
I'm wiring up the power walls.
Great. Have you ever wired up a stacked Powerwall before?
I've not. It's the first stacked one.
Sorry if I put a wire in the back of your head.
Okay.
It'd be by accident, I guarantee it.
All right.
What are there any complexities to wiring up a stacked Powerwall?
Well, I've not done one, so we'll see.
Okay, let me know what you find out.
All right.
What gauge wire are you using?
10 gauge wire for all power walls.
Nice. That's across the board.
Yep.
What kind of communication wire is in there? What was that?
This is, was this
Is that 16.4?
16.4 with the drain wire.
Shielded with the
Yeah,
train.
with
There
the
it
drain
is.
wire.
Nice. Do you know what the shielding's for?
Because we're running it with the higher voltage wires. Is that right?
Nice.
Right.
Dang. So the class 3 wire says 300 volts or more. Cool. Class 3 wire, so that's important. All wire in a conduit must be rated for the highest voltage present. That's real important. And you can mix AC and DC wire in a conduit, but not in certain circumstances, such as photovoltaic DC output. So you got to know your rules. There are a ton of 1,000 pages in the 2023 code book. 1,000 pages, right? Code updates every 3 years, so they're always throwing a curveball at you. But it doesn't mean your state or local jurisdiction adopts that code. For instance, last I heard, the city of Chicago is still on the 1999 National Electrical Code with the Chicago amendments. It's an animal. It's a beast. Chicago has a terrible history of fires. So houses in Chicago are wired in EMT. That's electrical metallic tubing. Right? That's the stuff you see in exposed work like at restaurants and stuff. It's hard pipe. Through the studs and joists and rafters of the home. That's pretty intense, but Chicago has a bad history of fires. So the northwestern part of Indiana, right in the Chicagoland area, they do the same thing because they identify as Chicagoans. So it's pretty intense. We've got this panel landed. It's ready to be energized. We've been inspected. The utility's been out here. If you missed part 1, you got to check it out here. So the way to do it right is you turn all the breakers off so that when you flip the main, there's no load, there's no draw. Because let's just say, it's unlikely in a residence, but let's just say that all these draws, all these circuits were calling for load, were creating demand. In a worst case scenario, you could hit this main and you could have 150 amps of instantaneous draw, which would put stress on the system and is not ideal, particularly in commercial environments where you've got motor loads that'll just kick on real hard. Motor loads are insane. A 15 amp motor might have a 45 amp startup inrush current. That's crazy. So what if you had 5 15 amp motors that could operate simultaneously under normal conditions? If you trigger an event to cause them all to come up simultaneously, then you're going to kick your main, overload your system. So breakers off, main is on. Always look away just in case there's an arc flash and bits and pieces go flying. Good precaution. We've got a bunch of spare breakers here. I've harvested the GE breakers that we pulled out that are not compatible with span, and I put all the spares in here. Spares, by code, have to be labeled as such. Every circuit has got to be labeled with a non-occupant specific labeling mechanism. So north, south, east, west is better than Bobby's room, for instance. In addition to that, every circuit must be labeled distinctly from every other circuit. So you can't have lighting circuit, lighting circuit, lighting circuit, lighting circuit. I've seen that so many times. Every label must be distinct, non-occupant specific, and spares must be identified. So let's just start kicking stuff on here. We still need to do label cleanup. We need to finalize the labeling mechanism. We need to blow out the panel. Woo, there we go. Garage lights. Just bringing them on. Nothing's arced or flashed yet. Hey, if you want to see a cool arc flash, check out this video right here. We actually tested it. Probably over 2,000 amps of fault current. You can see what that looks like. Nothing happened. Anticlimactic. Back to work. SolarEdge transitioned to screenless inverters about 2 years ago. So there's an app, you scan the QR code, go through the commissioning process. It's just a pretty clean step-by-step. But when all this is done, we still have our labeling to do. PV labeling by code. Our DC conductors in the attic are labeled as DC circuits so that nobody tries to splice into them and tap off for a kitchen receptacle for a sub-zero refrigerator or anything cray-cray, because that DC is going to be operating at about 370 volts DC on average. Just for context, the mains in here, 240 volts, so substantially higher, blow your stuff off the shelf. in addition to being DC, not AC. It ain't gonna work, bro. If you've got a similar situation, or maybe quite different to this setup right here, check the description. We've got a playlist of Powerwall, solar, and span videos that might be an assistance to you. In addition, we've got tons of electric vehicle charging videos, link in the description. And it's interesting to note that you've got some customers with 3 energy sources like this, where you've got the grid, you've got solar, and Powerwall. Sometimes there are 4 energy sources. Throw in a backup generator. Sometimes there are 5 energy sources. Throw in a Ford Lightning with vehicle to grid backup. It can get pretty crazy. This is beautiful simplicity. Tertiary, most of us are used to one form of energy, right? From the grid. Having a secondary with solar and a third with Powerwall is just super cool. All right, so there's a RJ45 port up here. It's Ethernet to home internet router. This one is for the communication. It's essentially the output to the input. So just a FYI there. I'm gonna shove the extra class 3 cat 6 down into the wall and then just tuck it back there. And
All right, so in order to start, we need to scan the QR code that is specific to each inverter. Then you take the red switch and you flip it over for just a second. That'll turn on the Wi-Fi that's being output by the inverter. Click continue in the app, and this can take a minute. Unable to connect, so you just retry. It does that multiple times. Oh, this is the set app, which is the app that we use to set up the SolarEdge inverter, to commission everything, to pair all of the optimizers with the inverter. It can be a little finicky to start up, and then there's a long wait period once you upload a new firmware. But after that, it's pretty easy. Yeah, you set it down. It takes about 20 minutes once firmware starts.
all right, let's throw this span breaker on. We're ready?
Let's do it.
All right, you gotta look to the lead man. All hands clear, look away. Anticlimactic. Boom, span lights are on. I'm gonna start throwing breakers. I don't know if your Wi-Fi's landed yet, but we'll get things to come on. Looking good, sounding good. You hear that breaker action? That's what you want, right? When a breaker loses that and it's sloppy and it wiggles, that's a bad breaker and you need to pitch it. But if it's tripped, it might feel like it's a bad breaker, but you just need to turn it off and then turn it back on and you should get that nice crisp snap action. Here's a little pro tip. If a breaker trips, it goes to that middle position. If it's a square DQO, it's got a little red flag. Sometimes, I'm talking like 2 times in 100, it won't actually go to the trip position. It'll be internally tripped, but the handle is still in the on position. So if you run your finger real lightly down, you think you got a power outage in the house, you're not sure, run your finger lightly down the breakers like this, and if it is tripped, it'll pop right over and you'll see it. Aha, I just prevented you a $205 service call. You can thank me later. A little cable management down here on this Cat 5. I'm just slipping it through the hinge. Take a thin zip tie. Don't crush it. Don't pinch the heck out of it. You don't want to deform cables, period, right? Communication cables or power cables. So it'll do that flash thing just to indicate, I can't remember what that indicates, but it's something intentional. And it's nice having that working light. Yeah, thank you, Span. All of these major components have a firmware. And according to our specialist here, firmware does not automatically update over the air like your vehicle. A technician needs to be on site, generally speaking, at least because they don't want your firmware to get caught in a loop and it doesn't come back on. Every technician, like solar technicians, when they're out here doing O&M services, when they're on site, they'll update the firmware, connect to the components, update the firmware, And that way, if it doesn't come back up, you're standing there and it doesn't generate a truck roll just to update firmware if things should go wrong. So that's interesting insight there. Check out this white conductor here. Here's a code thing for you. This circuit on a 2-pole 30 is an air conditioner, so the white conductor is terminated to the breaker. In this case, the white conductor is an ungrounded conductor or hot conductor. So it's got to be relabeled at terminations. The code allows for that when a cable assembly, because you can't, right, electricians don't manufacture cables. When a cable assembly has a white conductor, it's permitted as long as it's re-identified at terminations. Back to work.
So now we need to get the optimizers for the solar panels and the inverter all set up to talk to each other. And so you go in the app and you go to pairing, you wait a second as it loads. And this pretty much just takes everything down to 0 volts or like 1 volt. And then it slowly starts recognizing them and adding them to the system, I guess.
On here we have our operating voltage, which is standard is at 380. The max voltage we're going to see is 480. The short circuit current is at 30 amps, so everything's going to trip at 30. And then operating current is going to be roughly 21.05 amps. So I'm currently installing the Zigbee for the SolarEdge inverter. This is how we get communication when we don't run Ethernet. So we take this and we plug it in. We need 120 volt receptacle, and we need Cat5 Ethernet connection to this. So I'm going to go around to the other side, plug that into an open spot here. Okay, and that's it. So this will connect it to power. The way that this works here, the 3 bars tells you the strength of the signal between the Zigbee and the inverter. SOK means we have internet and we're connected there. And link, the number of flashes is the number of inverters that we have connected. So it's flashing once. That means we have 1 inverter connected. If it were to flash 2 or 3 times, that would mean we have 2 or 3 inverters. But we only have 1 today. So it's flashing once there. This is all good to go.
Timestamp, 7:07 p.m. I'm still super impressed, but let's wrap this up. About 60 to 75 minutes left if I had to guess. Plus cleanup, always plus cleanup. Tesla wall connector, which we did not install. When we relocated the circuit breaker and pulled on the metal flex, the conductors literally slipped out of the terminals and were hanging energized inside of that. Now, it wouldn't have harmed anyone, but if they had arced, it would have created quite the pop. So, little bits and pieces here to pull together. Camden found it. He's making the fix. Good work, Cam. It is now sweat dark 35. Camden has repaired the Tesla wall connector and determined the issue. Andy has gotten the power walls working here. I've almost finalized all of the circuits. We had a couple missing terminal screws from the breakers. It's just kind of piecing this. Guys, this is a big job to do in one day, start to finish. You got to have everything day one. If you split it across 2 days, then that second day is that grace period, right? We tend to crush them in a day. That's our MO. So, in that regard, sweat dark 35, back to work. But the good news is, I think I see a ship on the horizon. It is 8:27 p.m. The noun thief is at work. It's hard to come up with the information. I'm getting tired. I can feel it. Neck, legs, back. But I want to give you some information. We've got CTs on the HOTS here in the dummy panel. There's no tech in this panel other than the breakers, but the CTs. And these CTs are connected to the Tesla gateway. The Tesla gateway is kind of a central component from an energy flow standpoint in this equation, because the CT's current transformers are going to indicate to Tesla what the energy draw here is. So Tesla's connected to SPAN, so we've got insights. Tesla's got the CTs on the dummy panel, so we know what the draw, the consumption is. Tesla has the SolarEdge inverter landed in it and it's connected to the power walls. So this is kind of the brain box in this case. It's we're getting close. The area's been cleaned up, lots of shop vacuum later. Drywall and insulation and drywall are back in. We are closing in. Thank you, Camden. That's one thing that's sweet about a span panel. Single screw installation and removal. That's amazing.
Yeah, the gateway is the same way.
And then check this out. It's a snap cover. It looks fantastic. It's going to match the Tesla stuff because Arch Ralph, founder of Span, actually came from Tesla, brought Tesla Powerwall 2, maybe 1, and Tesla Solar Roof to market, which is cool. And then watch this, here it goes. As an electrician, I really appreciate that. It's like when you open the fridge and the lights come on, but better.
Stop me at any time. Okay, so when you're going through, it's going to ask breaker amperage rating. We've got a 200 amp, the main, the utility amperage, which here is 400. Flush mount kit is used, and the location is in the garage. It's not downstream of another panel. So we'll just keep chugging along here. Which battery system are you pairing with? So at this point I'm going to click none because we're still waiting on our Tesla batteries to get up to speed, so I'm going to click none for now, but we are using the Tesla Powerwall 2. We have one AC tied solar inverter, and there's no generator. We are not installing a span drive, and then I think we finally get to move into commissioning. Okay, network settings, Wi-Fi network. So we'll have to talk to the customer to get that information, but we can get that started at least.
So, been in communication with my wife. It is now 9:01 p.m. We've got an internal communication error on Powerwall 2, which has prevented us from updating the firmware, which is the first step in the commissioning process, which has prevented us from commissioning the span panel because it's a dependency on Tesla. So we've bypassed that step now because of time, 9:02 p.m. now, and we are done customer orientation. We've commissioned the solar. Span is in process, and I think we'll be home by midnight. No, it'll be before that. But we just need to set expectations and get some nutrients here. No one's had dinner yet.
Like Joel was talking about.
But it's been fun. It's beautiful weather today. It's been absolutely fantastic. You know, if you're looking to expand your electrical or solar energy business, let me tell you how to turn 10 grand in revenue per man per day. I wish I could do that every day, just some days. However, my advice to you, subscribe to Electric Pro Academy for real skills to make real money.